So for today's practice problem, let's imagine that we have a ball that we drop and it spends 2 seconds in the air and we want to know how far it fell. So if we drop it, we know the V naught is 0. Okay. If it spends 2 seconds in the air, then that's the time. And what you hopefully learned from your free fall lab or whenever is that the acceleration of free falling objects is always -10. So if we want to know how far it fell, then we can use the don't need v equation, which is d equals v naught t plus 1/2 at squared. So d equals 0 times 2 plus 1/2 times 10 times -10 times 2 squared. So d equals, let's see, that's that. 5 times 4, so -20. So why is my displacement negative? Well, because the ball fell from here to here, so if it starts and ends, then it has a negative displacement, a downward displacement. Okay? So that's pretty straightforward, right? Let's take it one step further, and let's imagine that we have a ball in our hand, and we throw that ball upward, and then it comes back down and lands in our hand again. Okay? Now we can time that, and let's say the time there is, 4 seconds. Okay? Well, if you watch the position time graph as time goes by, then you'll see that the ball goes up and then comes back down in a perfect parabola. And there's a couple things we can look over this, just the nature of parabolas or whatever else, but the idea is that the path on the way up and the path on the way down are actually going to be exactly the same. So what we can do is we can know that, well, that means that it takes 2 seconds to get up and 2 more seconds to get down. Which means what we can take from that is, if I want to find out how far the ball went up in the air, if it was in the air for 4 seconds, is the same thing, except we're going to cut this in half and have it start right here and end right here. If I start here and end here, my displacement is 0, and that's not very helpful if I want to know how high it went. But if I start at the highest point and end at the ground, then I can say my V naught is 0 because the ball goes up. And for that one split second right there, it doesn't move, right? It goes up and freezes and then comes back down for an instant, not even a measurable amount of time, but there's an instant there where it's not moving. And then again, if it's a free-falling object, acceleration is -10, and if time is 2 seconds and displacement is our question mark, then this might look familiar to there, and then we'd know, yada, 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 that my displacement is -20 meters. Therefore, my height of the ball would be 20 meters. So the key there is the time we used is half of what we call the hang time. The time the thing spent in the air, the time that we worry about, since we're only dealing with half the problem, the time that we worry about is half of the hang time. But once you do that, then A is -10, because A is always going to be -10 for something falling through the air. And V naught is 0 for anything that starts at the top of its path. And then displacement, just follow those steps, come to the equation, and you're good. Okay? So there you go.